Good day, ladies and gentlemen. Today we're gonna do a presentation about our ISAS project on algorithm and data structure, and that is bubble sort. But before of that, let's move to the next slide, please. This is the structure of our presentation. We're gonna do an introduction, and we move to background, analysis, and our closing. And let us introduce ourselves. Let's move to the next slide. Introduce myself. My name is Rafli Maulana.A.
My name is Nabana.Y.
My name is Karen Violanda.G.
And that is the member of our groups. Shall we begin? And this is the background. Algorithms and data structures are important components in computers. Algorithms are sequence or steps for solving computer programming problems, while data structure is a way of storing, organizing, and managing data in a computer storage media. Data can be used efficiently in data structures. The algorithm has several algorithm topics, one of which is searching and sorting. Searching and sorting are divided into several types. One of which is bubble sorts. In this task, we will discuss bubble sort, which is sort by comparison. Let's move to the next slide.
Okay, this is analysis. Before we talk about algorithm, and this is the bubble sort. Bubble sort is a fundamental algorithm for organizing a string of numbers or other components in the proper numerical sequence. As the string is examined from left to right, the technique checks each set of adjacent elements in the string and switch their locations if they are out of order. The algorithm then repeats this procedure until it has completed a complete run through the string and has discovered no elements that need to be switched. And next, there is types of bubble sort. There are two types. One is ascending and two is descending. Ascending is sorting data from lowest to highest, and descending is sorting data from highest to lowest. Next slide. We talk about steps of bubble sorting. There are three steps. One is compare the first data with the second, and two, if the first data bigger or smaller than the second, we have to swap the position. And three, the compare the bigger or small data with the next data and so on until it finishes. And next is the example, like ascending and descending. Okay, this is ascending. We have three iteration and the array is 5, 3, 9, 11, 8, and 12. In the iteration 1, we have 5 and 3. Is it 3 bigger than 5? No. And we have to swap the position. And 5 and 9, is it 9 bigger than 5? Yes. And we don't have to swap. And is it 9 and 11 is bigger than 9? No. And we fix the position. And is it 11 bigger than 8? Yes, and we have to swap the position. And then 11 and 12, is it 11 bigger than 12? No, and we have to fix the position. And this is the iteration 2 and iteration 3. It is the sum of interaction from again and then until the finish. And iteration 3 is the same. And the final, we have 3, 5, 8, 9, 11, 12. It's the smallest to largest. And then the descending example, before before we know there is the same interaction from the front until the end, and this is iteration 1 until iteration 6, and this is the same interaction. And we have the final is 12, 11, 9, 8, 5, 3. This is the larger to smalls. And bubble sort code will be presenting by Karen Ginting.
So this is the bubble sort pseudocode. First, I'm defining the function as bubble sort, and I take array as integer type. Then I store the length of my array in a variable called n, and I make temp variable as an empty string. Next, I'll create a boolean variable for my swaps, and I consider it as true first, because I need to be able to check if I've got swaps occurring. Then using iteration, I then check that while swaps equals to true, we are going to set swaps at false back to false. So starting from the end, we are taking the index one by one and putting the correct element in those index. So we first fill in the last index with the largest element, then the second largest element on second last index, and so on. We keep doing this until we reach the first element, the first index. So this loop represents it. And the first index we fill with the correct element is the last index that represented by n minus 1. Then we stop at index number 1, and each time we are going to increment I. Then this second loop, this second for loop is going to be the range which I'm going to shift the largest element to the end. Then this if j larger than j plus 1, then the value will save in temp variable. Then this j equals to j plus 1, it means that their position after swapping. After swapping, j will be in j plus 1 position, and j plus 1 will be in j previous position. Then will be an if and for and while and return the function. Next. This is the bubble sort dry run, the implementation of the pseudocode bubble sort. As we can see, this is the table for iteration 1, 2, and 3.
And yes, now we move to conclusion and suggestion. The conclusion of the presentation is bubble sort is a good and simple algorithm to sort a list. Good to use when memory space is limited, and the more data, the longer and the slower the calculation process. That's the minus. And the suggestion is don't use bubble sort when you want to sort when you want to sort a large data, because it will take longer and slower to calculate all of that. And let my friend Devandra will close the presentation.
Okay, thank you. This is all from us, and thank you for your attention, and goodbye.